Students, let's learn a new topic of rectification. Now, meaning of rectification is measuring the arc length here in maths. We can discuss the finding arc length of a curve using various methods. So there are mainly three methods. Number one is Cartesian. Next is polar, and third is parametric. So in Cartesian form, say in case if you find y is a function of x and the variation for x is known to you, so in that case, say for example, you have a problem something like this is the curve y equals to f of x, and you would like to find the arc length of this curve between these 2 points. Say this is P and Q. Okay, so you wish to find the arc length of this curve. So practically keeping a thread on this arc and measuring on meter scale might not be possible every time, and to know what that exact arc length is, we have some analytical method. With the help of that, it can easily be done. So if you know the variation between x is x1 to x is x2, it can easily be tried. So the arc length is given by s. It is between x1 to x2, integral between x1 to x2, it is root of 1 plus, you get dy by dx its whole square. The integration is taken with respect to x. Say for example, here in the same case, if you find there is x is another function of y, say for example, here is your x and y axis, okay, here is your origin, and here you find there is some another curve, something like this, and you would like to find the arc length between both, and you know the variation for y. So maybe here is your y is y1 and here is your maybe y is y2. So the arc length can easily be evaluated using another formula. It is integral within y1 to y2. It is root of 1 plus dx by dy its whole square. The integration is taken with respect to y. If you have a problem in polar, say for example r is a function of theta, and you have a problem something like here is the coordinate plane, your xy plane, and you have a curve something like this, and you would like to find the arc length using polar. So if you see, here is the variation, maybe theta equals to theta 1 to theta equals to theta 2, and your r is function of theta. So in that case, arc length is given by integral between theta 1 to theta 2. So it is root of r square plus dr by d theta and its whole square. The integral taken with respect to theta. Here in case if the problem is in parametric, in that case, say for example, x is one function of t, y is maybe another function, okay, of t. So in that case, arc length is given by, if you know the variation of parameter, so in that case it is between t1 to t2, it is root of, you get dx by dt its whole square plus dy by dt its whole square. The integral is taken with respect to t, and the whole discussion can easily be completed. Now all these results can easily be proved. You will find the proofs in multivariable calculus, any book. Of course, proofs are not very important from exam point of view. Here they can easily be proved, and based on alone just formula, you can easily answer examples. Now to answer examples of Cartesian, because there are two formulas, how will you decide on formula? Simple. If you find y is function of x and variation for x is known, better to use this formula. If you know x is function of y and variation of y is known, better to use the other formula. And of course there is no confusion about polar. If there is r is available in terms of theta and variation of theta is known to you, better use this formula. Parametric discussion formula is given to you, but this is kept in self-learning, so you can accordingly see the examples. Thank you. Let's see some examples in the next video. Thank you.